Hello, I'm back, and today we're going to start with multivariable calculus. So to do this, we're going to start with our first unit, which is reviewing of vectors. So let's go ahead and get started. So first of all, let's talk about what a vector is, in case you might have forgotten it. If you're like me, physics was not your strongest subject. So a vector, basically, it has two components. It has what's called magnitude and direction. In other words, it has a length and a place, and we can find out where it's going, basically. Now, normally we'll represent a two-dimensional vector with these type of brackets called chevrons, like 4, 5. If this vector is located at the origin, we can show a graphical representation of it. So in other words, we can draw like this. So if I have my origin here. Now, when you look at a vector, the 4 is in the x component, just like a point. But instead of being just an exact point, this is more, we can think of vectors as more like a slope. For example, the 4 would be our change in our x values, and the 5 would be our change in our y values. How that helps us is on the x-axis, if we go from the origin, if we go over 4 units and we go up 5 units, we can get our vector. And we draw our vector as an arrow, and we can put a little dot there. We definitely need the arrow because the arrow, again, is giving us direction. Magnitude is just another way of just talking about the length of our vector. The arrow tells us what direction it's heading in. So starting from the origin, we're heading to the point 4, 5. We can describe a vector in terms of its terminal and initial point. For example, let's say we have vector k. It has a terminal point of 4, -2. That's telling me where it ends. And if we have an initial point of -2, 5, in other words, this is where the vector starts, we can write the component form of the vector. So if we look at it kind of like graphically, here we are at the point 4, -2, and that's where we're ending up at, but we're starting at the point -2 up 5. So our vector would look something like this. That would be our vector. We can write the vector in component form, which is a very important form for us. The component form of the vector is just basically talking about from the start to the end, what's happening to our vector, or what's happening to our point. Where are we heading? Well, we're going down, and then we're going to go to the right. So example, we can say we're heading down 7 units and heading to the right 6 units. That's component form. The component form is a vector giving us direction, basically. So we can do that very simple by subtraction. We just take the end value minus the start value. So if we look at it in terms of vector, well, we are ending at 4 minus the x coordinate for the starting position, which is -2. And if we do the same thing for the y values, ending at -2, but starting at 5, so -5. And we would get 6, -7. Whoops, sorry for my chevron. So right, this goes right, and this tells us it's going down 7. So we can see that. We go right 6, down 7. So this is called the component form of our vector. Now, if we want to find the length of k, well, we can go back to our drawing right here, and this is just the Pythagorean theorem. So if I look at my component form, basically you can kind of think of your component form as, what if we started at the origin? Well, if I move at the origin, my rule says my component form, my vector says we're going right 6, down 7. So it would look something like this. And how can we find the length of this vector? We'll call this vector k, so we go k hat. If I want to find the length of that vector, well, it's simple. It's just Pythagorean theorem. So we would say to get the length of k, now to get the length of k, we use these double little absolute value symbols for the length of k. This is sometimes called the magnitude of the vector. And to do that, we just use the Pythagorean theorem. which is pretty simple here. If we look in terms of x, it's going to be 6 squared plus a negative 7 squared, which is square root of 36 plus 49, which is just the square root of 85. So that's the length of the vector, sometimes called the magnitude of the vector. We always use these little double absolute values. Sometimes we will call the vector, the length of the vector, its norm. It's just another word. The word norm will be used in multiple contexts. Often, you will have to understand the context to determine which norm I am referencing. We'll talk a lot about this as we go through the course. This is the notation for finding the length or a norm of a vector. So, if we're given the vectors r to find the length, we just use the Pythagorean theorem. So again, we can just think of this. My change in x, my change in y. Graphically, our vector, we go right 4, down 3. So how do we find the length? That's my little arrow there, sorry. How do we find the length? Again, we just use the Pythagorean theorem. So the length, or the norm, sometimes called the magnitude as well, is just the Pythagorean theorem. 4 squared plus negative 3 squared, so we get the square root of 16 plus 9, which just becomes 5. So there's the length of our vector. Now, the norm or the length is just the Pythagorean theorem. Now, there are three main operations that we can start doing on vectors. We can add vectors, subtract vectors, and we can do scalar multiplication. Multiplication, division, we'll talk a little bit about that later on. We normally, you might have heard about those called the dot product and stuff like that. Today we are going to look at two ways of doing each, analytically and mechanically. Analytically is just algebraically, which is honestly what most of us would probably do anyways. Mechanically, like what if we're looking at an image like we would in physics. So if we're given these following vectors, r is at 4, negative 3 is in the direction 4, negative 3, and s, remember this little thing right here, that little symbol right there, we didn't talk about that, it's called a hat. Like, I'm wearing a hat. And this is called, pronounced r hat. And this is just basically saying that this is a vector. S hat is given by the direction 2, 3. We want to find the following vectors analytically. And it's very simple, it's just algebraic. This is 2r plus 2s. So it's just 2 times 4, negative 3, plus 3 times s, which is 2, 3. If we simplify it, we get 8, negative 6, plus 6. Basically, we're distributing 9. And what we do is we just add the like parts. So the 8 plus the 6 becomes 14. The negative 6 plus the 9 becomes, of course, 3. And there we have it. There's our answer. So if you want to, you can try this one right here. This says r minus 2s. So r, which is, of course, 4, negative 3 minus 2 times s. You can pause at any time. Go back and you can watch the video if you like. Or just if you want to work ahead, that's fine too. Just pause it and come back to us. 4, negative 3 minus, this is 4, 6. And we do this, 4 minus 4, we get, 0, negative 9. There we have it. Now, what if I wanted to find the length of this, or the norm? Again, it's just Pythagorean theorem. It'd be the magnitude of r minus 2s, which would be the square root of 0 squared plus negative 9 squared, which of course is 9. Now if you notice, the length is positive. Length can't be negative. That's when we square, we get a positive. Length will not be negative. Okay, so be very careful with that. I hope we're doing okay right now. So this is kind of fun for me. I don't know about you guys. It's been a while. So I'm going to stop this video right here. But on the other side, if you go to part 2, I'm going to talk a little bit more. I'm going to talk about the other way we can do vectors using mechanics. And that's going to be on part 2 if you go to that. Okay? Thank you.